In this video, I will provide you with what I believe to be one of the easiest homes you could build, small houses. And you can even use this design for a garage. The building is 20 foot by 20 foot in both directions. It's square. And we're simply going to use a beam, maybe a 4x6 or a 4x8, to provide us with the slope of the roof. So all of the walls are going to be the same height, and I don't really even know if you're going to need footings. However, I will leave that up to you. So I went ahead and installed some 12 inches wide by 12 inches deep footings all the way around the perimeter if you think you're going to need them. And some of you are probably wondering, well, how thick of a concrete slab should I use? And I really won't be able to provide you with that information. Obviously, the thicker the better. 4 inches should be the minimum. However, if I was going to do something like this without any footings, I think I would use a 6-inch thick concrete slab. And even though all I have is one door and one window, you could always put more in here. And something else I want to mention is that the door and the window are in the non-load-bearing walls. The load-bearing walls are here and might require larger headers. And again, the wall framing studs can all be the same height. You don't need to get into cutting any trick measurements there. However, you can start with this wall height here and then angle these walls up and then build the back wall a little bit taller to eliminate the beam and the gable studs. And if you need more information on that type of a design, let me know in the comment area. The reason why I didn't provide it for you in this video is because it's going to make the project a little more difficult to build. Next up, let's go ahead and install our roof rafters, 24 inches on center, and I will not be able to provide you with any of the material sizes because the rafters usually need to be a little bit taller in areas where you're dealing with snow loads and can usually be a little bit shorter in areas where it doesn't snow. Next up, let's go back and take a look at the angle that you might be dealing with at this part of the roof rafter. This isn't going to be a square cut, even though you could make it a square cut, and you might choose to shape the top of the beam, cut a slight angle in it, or put some seat cuts in the roof rafters if you don't like this part of the design. Same thing in the front. We're going to be dealing with all of the pressure sitting right here at the end of the wall. And if you don't like that, just simply shape the bottom of the roof rafter there. Next up, we're going to nail some 2x4s around the perimeter of the top of the roof. This is going to provide us with 1.5 inches space between the back of the fascia board and the front of the roof rafters so that we can slide our shear panel or our stucco behind the fascia board. And of course, our gable studs. And of course, the band will go all the way around the perimeter of the top of the building. Next up, let's go ahead and install our fascia board. So if we're going to use 2x4s, we can use 2x6 for the fascia board. If you want to use 2x8 for your fascia board, then you can always use it 2x6 for the band to provide you with the gap that you need. And in this video, I didn't miter the fascia board. Again, trying to keep this easy and not complicating anything. So here is the 1.5 inch gap between the back of the fascia board and the front of the block or the side of the roof rafter. And if we're going to use plywood siding, we can just simply slide it underneath the fascia board and butt it to the bottom of the band here. Maybe leave a 1/4 inch gap if possible between the top of the siding and the bottom of the 2x4 to allow for expansion. Next up, let's go ahead and install our roof sheathing and then take a quick tour around the perimeter of the building here to wrap up the video. Any questions you have, feel free to leave them in the comment area. And I will be providing a second part to this video to provide you with a little more information about insulating the ceiling. So make sure you stick around and watch that one. Here is another viewer requested video, and by that I think this was just one viewer who requested this video about 20 times. So here it is, how to ventilate a shed roof, and not too difficult, even though you're not going to be happy if your building code requires thick insulation. For example, if I need R30 insulation, that's 9.5 inches thick, I need to use 2x12 rafters. And basically all you're going to do is drill some holes in the rafter blocks that you're going to be installing in between the rafters. And then make sure that the insulation is not going to be blocking those holes. And yes, trust me, I've seen that too many times where the framer comes in and installs the blocks with the holes in them, and then the insulator comes in and puts the insulation right up against the blocks. So make sure that the air will be able to circulate from the outside. Through the blocks, we're going to be attaching a screen to the back of the blocks. And this will usually be a galvanized metal screen that's usually going to have 1/4 inch by 1/4 inch holes in between the screening. And you can usually attach this screen to the wood with a stapler or even small screws or nails. And the reason for that will be to prevent creatures larger than those holes to get into your attic. And then we're going to do that on the other side also, to allow air to cross ventilate, to go from one side to the other side. And again, I can't stress this enough, you can't use a 2x8 rafter and then R30 insulation. So not too difficult, I hope, to figure out. And if you want to shape the insulation, you can do that also, just as long as we got the airflow there. Or you can install a board like we did here. And this is another common method used by carpenters. And with it, you can run the insulation all the way to the block, just as long as there's no way for the insulation to push the block up and again, block off the airflow. And you can use different sized holes or shapes. You can use a rectangular shape. You can cut squares into these blocks. However, I don't recommend installing a notch on the top or the bottom because you could be interfering with the perimeter roof sheathing nailing or the nailing required to attach the blocks to the wall framing plates. So this right here would be out. And of course, a larger hole might work better for you than drilling a bunch of small ones. Next up, let's go ahead and take a look at a soffit vent. And for a soffit vent, you're still going to need the holes going through the blocking. And I do realize some carpenters just remove one of the blocks. That could be another option if that's okay with your engineer. If not, you're going to be drilling holes in the soffit or purchasing materials that will allow for the proper ventilation. Next up, let's go ahead and try to help you figure out the size of the holes you might need to drill. And even though I couldn't find any specific information on a vaulted ceiling or a shed roof like this one, where we're dealing with venting individual roof framing bays or the area in between the rafters. So I'm going to use the standard rule of thumb, which is 150-to-1 ratio to be on the safe side, and the minimum space from the top of the insulation to the bottom of the roof sheathing needs to be at least 1 inch. So let's go ahead and break out our calculator, and I'm going to pretend that this area is 2 feet or 24 inches and it's 20 foot long. So to find the area that I need for the holes, I'm just simply going to multiply 2 feet times 20 feet to give me 40. Then I'm going to convert it to square inches by multiplying 144. That's going to give me 5,760 square inches of area here. And then I'm going to use the ratio of 150. So I'm just going to divide 150 into this number. That gives me 38.4 square inches. And then we're required to round that number up, which would be 39 square inches. Then I'm going to divide that number into 18.5 square inches. That's what I'm going to need on each side. And now that I have that number, I can either drill some holes or create a space that would create an 18.5 cubic inch space. And hopefully that makes sense. Now, the last thing I want to point out is to make sure that you check with your local building department for clarification, because their interpretation might be a little bit different. And if it is, let us know in the comment area, along with any questions you have about the video, and I will try to answer them as soon as possible. And thanks for watching. Don't forget to check out some of our other videos on YouTube. And if you can't find the videos on YouTube, make sure that you visit our website to find a complete organized list of all of the videos we've made so far.